Hello class, today we're going to talk about section 8.4, which is quadratic equations with the form ax squared plus bx plus c is equal to 0. By the end of today's lesson, you will be able to use that box method that we learned in chapter 7 to factor trinomials. So we're starting with 7x squared plus 29x plus 4. If you notice, the difference between yesterday and today's lesson is that there is that number in front. So there is going to be an a value other than 1 in these problems, and that's going to play a big role. So with the other problems, we started by looking at just the c value, or that back number. Today, we need to use both the a and the c value. So what we're going to do as our first step is multiply those two values. So 7 times 4, and that's going to give us 28. We're going to be finding the factor pairs of 28 now, so 1 and 28, 2 and 14, and 4 and 7. Again, we're looking for the pair that is going to add up to that middle number. So in this case, I have two positives, and I want to add up to 29. Where the box comes into play now is in the factoring part. So you're going to have that same box that we used last chapter. And since we're looking for binomial answers, it's going to be a 2 by 2 box. The first thing you need to put into the box, that top left corner, is always going to be that first term. So the first piece is always going to go in the top left of the box, and the last term is always going to go in the bottom right. The other two come from our factor pair that we had over here. So I can either plug in 1x and 28x to give me a total of 29x, or I can plug in 28x first and 1x second. It doesn't matter where those pairs go, just so long as they both appear once. Now, in order to do the factoring part, we are looking to take out the pieces that they have in common. So we're going to start with this column right here. So 7x squared and 28x. Both of those numbers can be divided by 7, and they both have 1x. So I can pull a 7x out of both of them. Then I need to use this value that I pulled out to find the rest of the factors. So 7x times something gives me 7x squared. That something is an x. So 7x times x gives you 7x squared. Then I'm looking 7x times something gives me 28x. That something is a 4. 7 times 4 is 28, and then we have the x on the end. Now I need to look at this second 2. So I've got x times something gives me 1x. That's 1, and then we double check by saying 4 times 1 gives you that final answer of 4. So last chapter, we had these outside pieces, and we multiplied to find the inside of the box. Now we have the inside of the box, and we're working out to find those answers. So our factored form answer is going to be 7x plus 1 times x plus 4. So again, we did this by multiplying a and c to give us the answer of 28, finding the factor pairs of 28, 1 and 28, 2 and 14, 4 and 7, seeing which pair added up to that middle value, that was 28 and 1. Always start with this left-hand column here, so 28x and 7x squared had a 7x in common. Then we multiplied. 7x times x gives me 7x squared. 7x times 4 gives me 28x. 1 times x is 1x, and 1 times 4 is 4. Go ahead and try this one on your own. So multiplying 2 and negative 10 gives us negative 20. 1 and 22 and 10, 4 and 5. That pair that's going to give us negative 1 in the middle is negative 5 and 4. Pairing up this first column, we get a 2q in common. 2q times q is 2q squared. 2q times 2 is 4q. q times negative 5 gives you the negative 5q, and 2 times negative 5 is negative 10 for those two binomial answers on the bottom. Other things that you're going to want to check at the beginning of these problems. So I would start by doing 10 times 30, which is going to give me 300. That's a pretty large number to work with. So another thing that you're going to want to check is to see if all of your values can be divided by something. In this case, we have 10, negative 35, and 30. All of those can be divided by 5. So I'm going to pull out that greatest common factor, just like we did in section 1 of this chapter, and write the remainders on the inside. So I pulled out the 5. 10 divided by 5 is 2. Negative 35 divided by 5 is negative 7. 30 divided by 5 gives us the 6. Now we're using that inside the parentheses values to complete our square. So I've got 2 times 6, which gives me a number of 12 to work with. So 1 and 12, 2 and 6, 3 and 4. The pair that's going to add up to negative 7 gives me negative 3 and negative 4. So now when I plug into that box, I want to start in my top left corner with that first value. So I've got my 2d squared in the top left and 6 in the back. Then I want to plug in those other 2 values, so negative 3d and negative 4d. That's how we broke up the negative 7d. And now I need to pull out what they have in common. So we're looking at 2d squared and negative 3d. They have d in common. So d times what gives me 2d squared? The answer to that is 2d. D times what gives me negative 3d? The answer to that is negative 3. 2d times what gives me negative 4? That's negative 2. And we double check, negative 3 times negative 2 does in fact give me a positive 6. So now that we've got our factors, we want to write out our final answer. One piece that we want to make sure that we don't forget is that 5 from the beginning. We factored that 5 out. So I'm going to start with the 5, and then my 2 pairs of parentheses are 2d minus 3 and d minus 2. So that 5 that we pulled out at the beginning doesn't go away, it just becomes part of our final answer. Go ahead and try this one on your own, factoring out the GCF first. So we pull out the 2, leaving us with a 3 and a negative 4 on the inside. So we're working with the factors of 12. The factors of 12 that add up to 11 are 12 and negative 1. So we plug those in for our 2 boxes along with our information that we already know. Completing the factor pairs, we end up with negative 3p minus 1 and p plus 4. That 2 from the GCF needs to come down and be part of the answer as well. Looking at this one, there's nothing to factor out in terms of GCF. 4, negative 1, and 7 don't have anything common. So we're going to start with 4 times 7, which is 28. We already went through those pairs. That's 1 and 28, 2 and 14, and 4 and 7. We're looking for a pair that would add up to negative 1. When you are looking at these, you will notice that none of those pairs actually add up. So if you cannot find a factor pair to get to your middle term, this is what we call prime. So what that means, just like a prime number, is it can't actually be divided into its pieces. So if you think about a prime number, for example, 7, 7 can only be divided by 1 and 7, or 1 and itself. So the only thing that can divide this polynomial here is 1 and itself, instead of breaking it down into smaller pieces of the binomials. Similar to what we had last section, we also want to be solving these quadratic equations. This is where, again, we need to have them set equal to 0 in order to be able to solve. So we're going to start by checking if there's a GCF. 4, 17, and negative 15 cannot be divided by the same number. So we've got 4 times 15, which is going to give us 60. So our factor pairs of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. So now we're looking for the pairs that can get us to negative 17. What you're going to notice is that there are 2 possible options. 3 minus 20 can give us a negative 17, and negative 5 minus 12 could also give us a negative 17. So how do we determine which one we want to use? You have to pay attention, like I gave you a hint in the last section, about that last sign. So negative 15 means that I need one positive and one negative. So I'm going to use 3 and negative 20 to complete the box. I'll show you momentarily why negative 5 and negative 12 would not work. So when I plug in, I have my 4x squared and my negative 15. The two pairs that I'm going to plug in are 3 and negative 20. So 4x squared and 3x have an x in common, so I'm going to pull that to the top. X times 4x gives me 4x squared. X times 3 gives me 3x. 4x times negative 5 is equal to negative 20, and that should have an x after it. And then negative 5 times 3 gives me that negative 15. If I had gone through and accidentally selected the wrong pair, so if I had used the negative 5 and the negative 12, what I would have gotten when I completed my box was a different answer. So negative 5 and 4 have an x in common. Multiplying, we get 4x on the side. X times negative 5 is negative 5x. 4 times negative 3 is negative 12x. But doing that last double check, negative 5 times negative 3 is a positive 15, not a negative 15. So that last box doesn't actually work out. So if you don't know which factor pair to pick, you can start by just guessing if you would prefer. And if the box doesn't work out, then that means you need to use the other pair. If you don't want to go through and guess and you want to be sure about your answer, pay attention to that symbol with your C value. Since it's negative, you wanted one positive and one negative value. So now we have our factor pairs of 4x minus 3 and x minus 5, or excuse me, 4x plus 3 and x minus 5. And those are both equal to 0. So now I have to go through and finish the solution portion of this problem, and that's to set each factor pair equal to 0. So first we have 4x plus 3 is equal to 0. Subtract 3 from both sides, I get 4x is equal to negative 3. Dividing both sides by 4, I get x is equal to negative 3/4. If you are getting a fraction value, please leave those in fraction form. We do not want the decimals right now. So we have the second pair of x minus 5 is equal to 0. Adding 5 to both sides, and I end up with x is equal to 5. So our two answers are here are x is equal to 5 and x is equal to negative 3/4. Go ahead and try this one on your own, remembering to check for a GCF first. So we pull out that GCF of 2. After we multiply, we're looking for the factors of 70. The ones that add up to 19 are 14x and 5x. Then you're going to go ahead and deal with those factor pairs in solving. That 2 does not have to be set equal to 0 because it's not part of a factor pair. If you notice, that's why it's crossed out right here. It's still part of the factored form, but it's not actually part of how we solve. So our answers end up being x is equal to negative 7 and x is equal to negative 5/2. If you have questions about this or anything else from the lesson, please let me know when you get to class.